Hello class, I wanted to do a little lecture on linear equations, and before we get into that I wanted to do a review on plotting points because we will be graphing some of our linear equations, so you'll need to know how to plot points. If you already know how to do this, you can go ahead and move forward into the video, skip this slide. If not, this should be a good review for you, just to remind you of how to graph plot points. So let's look at what we have here. Remember, your ordered pairs are going to be x value first and then your y value. And when you're plotting points, you should start at the origin, which is the point 0, 0. So if we make red dot on there, that's our starting point. That's like your home spot, and you're going to use the ordered pairs as directions to get to where the point is that we're talking about. So the first value, the x value, either tells us if you're going to be moving left or right. So think of left as your negative values and right as your positive values when we're talking about the x-axis. The y value is going to either move down or up. So up is your positive values, down is your negative values. So let's look at our first point here. We have -5, 4. So in the x direction, we're moving -5. So that's a left direction. And then +4 is an up direction. So let's figure out what we have going here. So left, again, remember we're starting at the origin, or 0, 0. We're moving left 5. So 1, 2, 3, 4, 5. And then up 4 from that point is 1, 2, 3, 4. And that's going to be our point. It's left 5, 1, 2, 3, 4, 5, up 4. So that would be considered the point -5, 4. Okay, let's look at another one. So this one is saying 4, so that's a right or left. So a positive tells us right. And then a -3 is telling us that we're moving down. So again, we're starting at the origin. We're moving 4 to the right. 1, 2, 3, 4. And then down 1, 2, 3. So that's our ordered pair, 4, -3. Okay. And as I'm going through, if I'm moving too quick, remember you can always pause the video. So the next one is 0, 5. So 0 means I'm not moving left or right on the x-axis. We're staying on the y-axis here. And then +5 tells me to go up 5. So 0, up 5, 1, 2, 3, 4, 5. So that's 0, 5. And then the second one, let's change this. Looks like I wrote it backwards. So let's do -6, 0. So the -6 tells us that we're moving left, and we're going to stay on the x-axis. We're not moving up or down. So 1, 2, 3, 4, 5, 6, and we're not moving up or down. Okay, before we move on, let's try one to see if you can spot the right point. So let's try -2 comma -3. So take a moment, pause, and try to do that one. And then when you're done, come back to the video. So this tells us left, and this tells us down. So left 2, down 3. Okay, so -2 comma -3. Okay, so hopefully you were able to plot those points, and just a little refresher before we move on to linear equations. So it'll be helpful if you take notes as you're watching, and if you feel like you're familiar with something, you can fast forward. If you need to slow down a little bit, remember you can always pause. But it is helpful to actually take notes as you're watching the videos. Okay, so linear equations have a few different forms. Two of the forms that we're going to look at are standard form and your point-slope form. So for standard form, we have ax plus by equals c. So for a linear equation, notice the exponent on your x and y is a 1. If we get a squared here, then it changes the shape of the graph. So for a linear equation, we want our exponents to be 1. And this would be an example of a standard form linear equation. What this is good for is it's easy to find the x-intercept or the y-intercept. When it's in standard form, those are pretty easy to find, and we'll look at that in a little bit, but this is just to give you an idea of the different forms. Slope-intercept form, this is one you may remember a little more, y equals mx plus b. This form allows you to find the slope, which is your m variable, and the y-intercept, which is the point 0b. So you can see where the m is located, where the b is located. So for our example, these are the same lines, they're just in different forms. The m, the slope of this line, is the value in front of the x, -2/3. And the y-intercept of this one is at the point 0, 3. So we talked about graphing points earlier. So once you have a point and you have a slope, you can graph the entire line. So that's what's pretty nice about having it in this form already. It's pretty useful to find these parts and also for graphing. A couple other types of lines that you'll run into is a vertical line. So this is an equation where you're missing the y value. You just have x equals some number. Okay, so in this case it's x equals 5. So this is all ordered pairs where x is 5. So we wouldn't be able to list all of these, but just to give you an idea, this is what we're working with. We have x, and then all of our y values. So it could be the point 5, -3, 5, 0, or maybe 5, 2. These are all points on the line 5 equals x. So if we graph those points, they're all going to be over to the right 5. 1, 2, 3, 4, 5. We have the point 5, 0. We have the point 5, -3. And also 5, 2. So this will give us our line. That's our vertical line, x equals 5. So it's sort of a special case that you're dealing with there. And another one is a horizontal line. And this is an equation where we just have the y variable and a value. We're missing the x. So same idea. is you're going to have all the ordered pairs where the y value is -3. So if we have -3, -3, -3, again, we're not going to be able to list any of them. Really, when you're making a line, you need 2 points, and that will get you enough information. So again, it won't matter what values you pick here. All of them are going to be on your line y equals -3. And so we have 2, -3, we have 0, -3, and we have -1, -3. These are all example points that are on your horizontal line. Y equals -3. Okay, so those are sort of some special cases of dealing with linear equations. Let's move on to talking a little bit more about standard form and slope-intercept and using tables, those types of things. So for this linear equation, there's going to be different ways to graph. We've sort of looked at using ordered pairs on that previous one. And that's the same idea here, is you're going to make a table, plot those points, and then you can connect them to make your linear equation. So let me show you how to work through using a table. We have an equation, y equals -2x plus 3. Think about what form this is in. Yeah, this is in our slope-intercept form. So let's start with making our table for -1. So -1 is the x value. We're going to plug it in and find the y value. So I'm going to have y equals -2 times -1. Remember, when a variable and a number are right next to each other, they're being multiplied, plus 3. And we're just going to simplify here to get our answer. So -2 times -1 is 2, plus 3, so y equals 5. So this is our first ordered pair that will be on our line, -1, 5. We can plot that one in red. So -1, so left 1, up 5. 2, 3, 4, 5. So there's our first point. And we just work our way down and create our table by plugging our values in. So let's do our second value. So this time x is 0. Same idea, we're going to plug it in. -2 times 0 plus 3. So y equals -2 times 0 is 0 plus 3. So y equals 3. So this time we have the point 0 was our x that we used, and we arrived at a 3 for the y value. So 0 up 3. Okay. So notice that this is also considered your y-intercept because it's on the y-axis. And look at the b value that's over here. Remember, we said that the b value was your y-intercept. So as you get comfortable and you know it's in the form, this is one point you should be able to look at this equation and go, there's one point, I already know one, let's get it done. Okay, now the next point, why don't you try these last two real quick on your own and see if you can come up with the values. Pause me and then come back. Okay, so hopefully you've tried now. So we're trying with 1. So y negative 2 times 1 plus 3. So y equals negative 2 plus 3. So y equals, so I have the ordered pair 1 from my x, comma, okay, so 1, 1. And our last one is 2. So we have y equals negative 2 times 2 plus 3. So let's get another color. Plug in 2. And we have y equals negative 4 plus 3. Y equals negative 1. So we have the point 2 comma negative 1. And 2, negative 1. Okay, so you can see our line that's being created here from those 4 points. Really, we could get away with 2 of them, but we did before. And as you get more comfortable, you'll be able to use this slope as sort of your rise and run. So that negative 2 is telling you that your line is going to be going down 2, positive 1, down 2, positive 1, down 2, positive 1. And that will keep on going and create more points. So that's another way that we'll look at graphing too. So let's make our line here. It's going to go in both directions. So that's making a table of values. You can use it to graph, or you can just make a table of values. Okay. Let's look at standard form. So we talked about standard form a little bit, and we discussed that this is good for graphing when you just find the x-intercept and y-intercept. So to find the y-intercept of line, so where it crosses the y-intercept, we have x equals 0 every time. So x is going to always be 0 when you're finding the y-intercept. And y is going to always be 0 when you're finding the x-intercept. So what I can do is that same idea of making a table. So I'm going to plug in 0 for the x to find the y-intercept, and I'm going to plug in 0 for y to find the x-intercept. So let's see what that would look like. And again, remember we need 2 points to get our line, so this will give us enough. Alright, so let's do the first one. We're plugging in 0 for x. So I have 2 times 0 plus 3y equals 12. And we have 0 here. So 2 times 0 is 0. So that's the nice part about doing this process, is your variable is going to cancel out. That's just going to leave us with 3y equals 12. And to solve this, we divide by 3, since we have multiplication here. And that gives me y equals 4. So my first ordered pair is going to be 0 left and right, but up 4. So this is my y-intercept. It's where the line intercepts or crosses the y-axis. Okay. The other one that we have is our x-intercept. That's when y equals 0. So we have 2x plus 3 times 0 equals 12. So this time we're plugging in 0 for y variable now. So notice that we plugged it in for the y. Same idea, 3 times 0 is 0, so you're left with just 2x equals 12. Divided by 2. That's a bit of multiplication again. And that leaves us with x equals 6. So our x-intercept is 6 to the right, up and down 0. And then if we connect our dots here, hopefully yours are connected a little better than mine. If that gives you the idea. Get a little closer. So you can use the x-intercept and y-intercept to also find the line, or to graph the line. Okay, and when it's in standard form like this one is, the ax plus by equals c, this is usually your best approach. Let's look at slope-intercept form and using the slope and the y-intercept to graph our line. So ideally this is what you get to, this is probably the fastest route because you're not making a table each time, you're just looking at the parts. The only thing is you need it in this form. So notice with this form we have a y isolated. It's not a 3y, it's a y, so there's just a 1 in front. So your goal is to move everything away from y. So what we have is, right now we're in standard form. This is the equation that we were just working with. So we're going to put it into slope-intercept form by moving everything over. The first thing we want to do is move x over. So I'm going to subtract 2x from both sides. So that's going to give me 2x minus 2x is 0, so we're just left with 3y. Now, a habit here that I see a lot of times is, since we're subtracting, people like to put it behind the 12. But if you notice our form, the x term comes before the constant. So when I write this, since they're not like terms and I can't actually combine them, I get negative 2x, and this is a positive 12 since it's not showing a negative there. Okay. So we're close. The last step is to move the 3 over. Again, it's being multiplied, so we have to divide it. And make sure you divide everything by 3. And that gives us y equals negative 2/3 x plus 4. Now our goal is, we're in slope-intercept form. Let's find the y-intercept and use the slope to graph these. So remember, our y-intercept is where it's going to cross the y-axis. So this 4 here tells me that the y-intercept is at 0, 4. So that's one of my points, 0, up 4. Now the other point is found using the slope. Now you may have heard the term rise over run. So that's telling you that the value in top is the rise. So it's going to tell you up or down. And the run is going to tell you left or right. So we're going to start this time from the y-intercept because we're trying to graph the line that goes through this point. So -2 tells me that from my y-intercept, I'm going to go down 2, and +3 tells me right 3. Okay. Technically, that's enough to get our line. We have our 2 points. But this down 2, right 3 keeps going. And what else happens is -2/3 is the same as 2 over -3. That negative can float. So the 2 would tell me that this time we're going up 2, and the -3 tells me I'm going left 3. Notice I'm still on the same line, just on the other side of the y-intercept. Same idea, this process continues. And then you connect them to get your line. And if you go back and look at the previous one, you'll see that these are the same lines. We just use different methods to get them. Okay, this still has the same as down 2 over 3, down 2 over 3 to get to the values. So it still has a slope of -2/3. It's just different ways of graphing the line. Okay, the last thing that I want to look at is just an application of linear equations. So when you're working with an application of linear equations, what you usually have happening is you have a rate or cost per item. So in this case, we had each ticket for a concert costs $50. Okay, or if you're thinking about a taxi, each mile that the taxi takes you charges you maybe 30 cents. Okay, those are happening depending on how far you go or how many you buy. That's your rate. Now, a lot of the times, the other part that you'll have is there'll be a fee, a one-time fee. For this one, there's a parking pass. So you're going to be driving there. The concert ticket gets you in the door, but to park your car, you have to pay that additional $10. Or, again, back to that taxi idea is if usually the rates for taxis are when you get picked up, there's a cost for picking you up. Maybe it's $5 to start with, and then it's 30 cents per mile after that. So that cost per item is your slope. Your slope. Okay, this is your M value in your formula. The one-time purchase is your B. That's like your starting point. You have to spend the $10 to get your car there. If there's 4 people in your car, then that's going to change the price. Or there's 2 people in the car, maybe just you in the car. Those change, but to get the car parked is a flat fee of $10. Okay? So if we want to write a linear equation to represent this situation, we have y, which is going to be our cost, the total cost, equals our slope, which is the cost per ticket, so $50, times x, plus the cost to park the car, which is $10. Okay, so this is a linear equation that represents our situation here. If you wanted to change the variables a little bit so that they represented the actual item, so y represents the cost, so we could use a C here. The cost of going is $50 per ticket, so I could use T instead of X, plus the $10. Okay, so this is still a linear equation. We're just using variables that represent the items that we're talking about. Okay, so now that we have a linear equation, we have the cost equals $50 times the number of tickets plus $10 for parking. We can figure out the cost of how many tickets and a parking pass. So this is telling me that t equals 3 here. So I'm just going to plug in 3. So the cost equals $50 times the number of tickets, which in our case is 3, plus the $10 to park the car. So we have the cost equals 50 times 3 is 150, plus the $10. So the total cost is going to be $160 when you combine those. So that's setting up a linear equation to represent your situation and then solving the linear equation for a specific situation. Okay. So I hope that was helpful. Just a little introduction, little lecture on linear equations and the different parts, different types of linear equations, different forms that you're going to see. Remember, you can always go back, rewatch the video, those types of things. Hope you have a good day.